Okay, for this next section, we're going to be doing two parts of 5.1. We're going to be doing the solving part, and we're also going to be doing some application problems. So the first thing I want to look at is solving for the solutions. A big part of this chapter is solving, and we're going to be solving by graphing, quadratic formula, finding the square root, completing the square, and factoring. So graphing is just one method. And you might see it as say solve by graphing. It could say finding the zeros. And when you see how to actually use the graph to find these solutions, you're going to see how that term, finding the zeros, is going to make a little more sense. When you're looking, you graph it just like we have been doing, either by hand or on your calculator, and you're going to be looking for the x-intercepts. Wherever the graph hits the x-axis, that's going to be considered your solutions. Okay? Most of the time, many times, there's going to be two. Since we're looking at the parabolas going up or down, it's going to cross the x-axis twice. Okay? So an example here, f of x equals x squared plus 8x plus 15. I'm just not asking you to trust me and doing this quickly. Negative 4, 1, negative 1, and the graph goes like that. Now, when you're looking for the solutions, okay, you're looking at the x-axis. Okay? Wherever the x-intercepts are, there will be the solutions. So a set of solutions here, x equals negative 3 and x equals negative 5. Don't write it as an ordered pair, or if you're going to write it as an ordered pair, it is negative 3, 0 and negative 5, 0, but don't put the negative 3 and the negative 5 together. It is two separate answers there. Okay? So a lot of times you're going to have to estimate. If you're doing it on a calculator, you might be able to zoom in. This is why graphing, your graphs have to be fairly accurate so you know exactly where it crosses the x-axis. Okay? If you get a situation where it only hits the x-axis once, meaning the vertex is the only part that hits the x-axis, you may only get one solution. So let's just say, just another example, if your graph goes like that, and the vertex is the only point that hits the x-axis, that's going to be considered your only solution. So a graph like this, or a parabola like this, only has one solution, x equals 6 in this case. What if it never hits the axis? Let's say a graph that looks like that. Well, we haven't talked about it yet, but that means that your solutions would be imaginary solutions. And we'll talk more about that when we get to section 5.5. Okay? But if it doesn't hit the x-axis, that means there's no real value that could solve this solution. It would be considered imaginary. Okay? So that's a possibility. Okay? So there's actually three possible outcomes. You could have where it crosses twice and you would have two solutions, where it hits the vertex on the x-axis and you have one solution, or a case where it doesn't hit the x-axis at all. In that case, you would have imaginary solutions. Okay? So that's going to be solving. The graphing part's the same. Finding where it crosses the x-axis, that's the new skill. That's where your solutions are. Now, we're going to do some application problems. So, word problems are application problems. A frog's leap can be measured by the function h equals negative 1.778t squared plus 5.334t minus 0.0005, where h is the height of the jump in inches and t is the time of the jump in seconds. Okay, one thing I do like to do with these, since we usually deal with x and y, I always kind of like to put y here and x's where my x's usually are. I know these are h and t's, so it looks a little different. This kind of helps me just stay a little more organized with the calculations that we usually do. The questions are going to be things like, what's the frog's max height for a jump? Okay? How long does it take a frog to get to their max height? Okay? The important thing here, I'm asking for the max. Okay? And what we learned so far about graphing, the max is the vertex. The max is either going to be the highest point, or the vertex is either going to be the highest point, which is the max, or if it's opening up and it's a smiley face, it's going to be the minimum value. So in this case, it's asking for the max. There's two ways you could do this. One, you could use your calculator. Okay, graph on your calculator and use the max-min function to find that vertex point. Or you could use the formula that we had. You can still use that negative b over 2a to find your x value, and then plug it back in to get your y. That's gonna be up to you. Take your time. If you're good, a lot of people like the calculator, if you're good at adjusting the window, because sometimes the graph will not fit in your normal 10 by 10 screen. You're gonna have to adjust the window to what your graph is. I'm gonna do this example with the formula there. So I have negative b over 2a. Just take your time when you're plugging in. Okay. So you have negative 5.334, which is our b, 2 times negative 1.778, and this is our t value, or our x in this case, and we should get, I have 1.5 for our t value. Now when you plug 1.5 back in there, negative 1.778, 1.5 squared, plus 5.334 times 1.5, run out of room there, minus 0.0005, so I had to squeeze it in there to fit the whole equation in. Okay, plugging that in, you should end up with 4. So our h is 4. Now answering the questions here, knowing what h and t is, what is the frog's max height for a jump? Well, that's our h, and we just found that as h. So that means that our frog, where h is the height in inches, its max height is 4 inches. How long does it take a frog to get to their max height? That's 1.5 is time, and that time is in seconds here. So that's 1.5 seconds for our calculations. Okay. Now once we have that, the next question then is, what is the frog's hang time? So let's think about what this parabola would look like, even without graphing it. We know since our a is negative, it's on an open down. That vertex is that point there. So once you find that vertex, you gotta know, okay, well, if it took, the height is 4 inches, it took 1.5 seconds to get there. Well, if it takes 1.5 seconds to go up, it takes 1.5 seconds to go down. Total hang time is when it leaves the ground and then hits it again. 1.5 up, 1.5 down. 3 seconds is on our hang time. Okay? So there's an example application problem. 2 ways you could do this. Either using your formula, negative b over 2a, or you could graph it on the calculator and look at the graph. You might have to adjust your window to see where it is, but use that calculator function. Okay? I'm going to do one more example here with the formula. Here we have, the club's profit from booking local bands depends on ticket price. Using past receipts, the owners find that the profit P can be modeled by the function P equals negative 15x squared plus 600x plus 50, where x represents the price for a ticket in dollars. Okay, what price yields the maximum profit? What is the maximum profit? I'll tell you now, I would like you to at least try it on your calculator. For this problem, you will have to adjust the window. Think about what your x and y is. X is price per ticket. Think about how much you would spend for a ticket. Okay? If you're going to a concert, most likely, unless you're going to someone extremely famous, you're not spending any more than $100, $150. Okay? Think about profit. We're looking at maximum profit for a club. How much do you think a club makes a night when they're actually having a band there? Okay? And try and put in those prices for your X and Y values. Now, those are kind of tricky, which, again, we're not club owners. Use the formula. Negative b over 2a is going to give us our values. We have our a, we have our b, negative 600 divided by 2 times negative 15. And that's how you give us our x value, and that x value should be, is it $20? I just want to check my math here real quick. Okay, so we have $20 for our tickets. That's our x value. Now plugging that back in, oh, 20. Okay, negative 15 times 20 squared plus 600 times 20 plus 50. That would give us $6,050 for our P. Okay, so when it's asking you, what price yields the maximum profit? Well, the price would be $20 a ticket. Abbreviating there a little bit. And what is the maximum profit? $6,050. So there's looking at another example using the formula again. Try it on your calculator, adjusting the window. Okay, make sure you're just thinking about realistically, how much would it be and what profit would they make with that.